Hello everyone, welcome to my YouTube channel. Today we are going to discuss Jacobi's method for finding eigenvalues and eigenvectors. This is given matrix A, and here 3, 5, 3 are our diagonal elements and others are non-diagonal elements. So first of all we take largest non-diagonal element, that is A13, that is 2. We take it and from this row. So now in this diagonal, which elements are equal? That are A11 element, that is equals to A33 elements, and its value is 3. So we know that tan 2 theta, that is equals to 2 times into largest non-diagonal element, that is A13, upon A11 minus A33. So here we substitute the values. 2 into 2 upon 3 minus 3, that becomes infinite value. So tan 2 theta, it becomes here pi by 2, that is theta is pi by 4. Next we find transformation matrix P1 or orthogonal matrix, that is P1. Here we take it in the form of this. Now in the diagonal element row, which are equal, that are A11 and 33, here we take cos theta, cos theta. Next, in the non-diagonal elements which we take, here we take it as minus sin theta and sin theta. In this row, we substitute here 0 and here 0, here 0, here 0. So this element we take it as 1 because now it is orthogonal matrix. So again in diagonal elements we take cos theta, and non-diagonal element we take it our sin theta. So in this form we can become this value orthogonal matrix. So here we substitute the value of theta, that is 1 by root 2, because cos pi by 4 is 1 by root 2. So it becomes this matrix P1. Next, it is orthogonal matrix. So P1 inverse, that is equals to transform of P1 matrix. So it becomes this. So the first transformation gives, that is our A1 matrix, that is P1A into P1 inverse. So here we substitute the three values. In this way we get our A1 matrix. So here non-diagonal elements exist. So now we next find our other transformation matrix. So again in A1, the largest non-diagonal element, only this value. So these values are A23 or A32 and it are 2 root 2. So in diagonal, which elements are equal? These two. So A22 and 33, that is equal values, that is 5. So tan 2 theta, it is equals to 2 into non-diagonal element value, that is A23, upon diagonal values which are equal, that are A22 minus A33. So here again we substitute, we get infinite value. So in this way tan 2 theta is pi by 4. So theta becomes pi by 4. Next, transformation matrix P2 or orthogonal matrix P2. So now we take here 5 value. So here we take cos theta. So non-diagonal elements we take it as minus sin theta and sin theta. So in this way, here we substitute value 0. In this way, here we substitute value 0. In this way, here we substitute value 0. Here, so its values become 1. So next, P2 transformation matrix, it becomes 1 0 0 0 1 by root 2. Here again we substitute the value of theta, that is pi by 4. So it becomes 1 by root 2. So in this way we get our P2 matrix. Next again we find P2 inverse. Same, we here find transformation matrix, transform the matrix. So we interchange row into columns. So we get our P2 inverse. So the second transformation gives A2, that is equals to P2 A1 into P2 inverse. So here we substitute the value of P2 A1 and P2 inverse. We get this matrix. So it is here exist only the diagonal elements. So this is our exact transformation matrix. So in this way we get our eigenvalues that are exist in diagonal elements. So the eigenvalues are 1, 5 minus 2 root 2 and third is 5 plus 2 root 2. So next we find the eigenvectors, and the eigenvectors are columns of product of the matrix P1 inverse and P2 inverse. So here we substitute the value of P1 inverse and the value of P2 inverse. So next we product these two matrices. So in this way we get this matrix. So our eigenvectors are, first eigenvector is this and second eigenvector is second column and the third column is our third eigenvalue. So in this way we can find our eigenvalues and eigenvector. Thank you so much. If you have any doubt, please write in comment section.